Okay, so everybody, it's week 10, and it's Thursday. It's Plastics Week, as you know, and we are very fortunate to have our own Eddie Stan here today. He's going to give a little bit of an intro for the first 20 minutes or so. We'll take a break, then he's going to give a nice little hands-on, and then maybe some discussion and conclusions for the third portion of lectures. So I'm sure your voice will pick up the microphones here on the laptop. So, all right, with that, I'll give it to Eddie. And I can also, if you need me to go to a website or whatever during the lecture, let me know. But other than that, I'll just sit over here with the camera on you. So take it away, Eddie.
So, as you know, plastics made it possible. So plastics are ingrained in every and each facet of our life. They're omnipresent even when we don't even realize that they are there. We wear plastic glasses. We have plastic tags attached with plastic gizmos, plastic light. Plastics are all over the place, and we, most of the time, have no clue how they came there. We bought them at the fancy shop. We bought them online. We bought them somewhere. At the end of the day, when they break down, because they do break, in the end, what's going to happen to them? Well, at the end of the day, they have to go somewhere. And it's our decision. Most of the time,
Oh, yeah.
and most of the people do just this. They drop it in the trash, in the bag, to never retrieve it again. But us, we are different. What we do, we take it from the trash stream and we put it back to use. Believe it or not, this plastic might be made out of virgin materials, which is mainly crude oil, but it might as well be made out of recycled plastic, which means it's been used, by the color of it, could have been used at least twice before it became this tag. And the reason why, from the crude oil, from the material that we extract from the ground, we process the plastic into, most of the time, something that's called in industry the natural color. It's either transparent or translucent. So it looks really clean. Once we start recycling through the technology, we can always separate. But because of the technologies, separation, it's not 100%. There is a tolerance in the separation process, so the transparent plastic or the translucent plastic that you'll see in the second stage of our demonstration becomes a little cloudier. So what the industry says, hey, it's not all the way transparent, we're going to add a little bit of tint to it, and we're going to make it smoke colored, or we're going to make it a light shade of green, a light shade of something, a degree of transparent, which is maybe 5% in transparency lost, which the human eye doesn't quite perceive, but it's been contaminated once. Then we recycle it again, because there are a couple of plastics with extremely wide usage, which we named number 1 and number 2. I wonder why. Number 1 and number 2 are something that are called indefinitely recyclable, which means that we can take the same material, we can process it again and again and again and again. And the cycle, in theory, it's unending. Our technology, though, has the fault of precision. So we do not do 100% sorting. We do not do 100% cleanup. So every and each time we cycle again the same material, extra impurities go into it. So the one that was 5% contaminated and became a transparent with a shade of smoke or a little green, or not so transparent anymore, a little translucent. Then at the end of second or third cycle, we put a little pigment. We put color into it. We make it from transparent, we make it into opaque. The base material is the same. We just added a colorant, another chemical into it. Most of the time it's an inert material. It's a material that will not change the chemical structure of the material. It will change some of the properties. It will make a little less flexible. So I will not be able to bend this one 25 times before it breaks, like I would do with this. They are exactly the same material, but it serves the purpose.
But would
Yes.
it be considered more contaminated at that point?
It
For
would,
recycling?
it would be considered more contaminated, but not necessary, because it's a different material. So the analogy with food, wheat. If we gather it straight from the field, we take the chaff away, and we did it for a few tens of thousands of years, pop it and eat it. That's your number one plastic at the first usage. It's coming from the virgin material, you use it. Do you eat crude wheat? No, you don't.
so much.
But I bet what you do, you eat bread. You know what bread is? Wheat contaminated with salt and yeast. Two contaminants. It's not the same, but your body still uses it. It's a different product. Contamination sometimes makes it better instead of making it worse. So it's not necessary.
Better for use, but not better for the environment.
Not necessary. Again,
It just all depends.
it all depends. White, you can make white with zinc oxide, which is fairly common. It's a very bright white. Or you can make it with talcum powder, which is an inert material. It's a dust that it's natural, and it will go back into the environment without harming anything. In small dosage. Always dosage, it's important. It's too much of the good thing, it's not a good thing. So, at the third or fourth, it becomes white. After that, again, I can recycle it again, and the same plastic goes through the whole rainbow colors. And at the end of its life, it becomes black. So many times the most contaminated plastic, it's black in color. Why? Because it can take all the colors of the rainbow, it can take all the contaminants, and it shows to the human eye that this could go into the ground, could go away. It's a social convention, but it's the easiest technological solution to indefinite recycling. Surprise, surprise, most of our bags are not, at the end of the lifetime, they were made out of crude and they were pigmented black from the very beginning. Why? Because it's the easiest and the cheapest process. A ton of, so in order to make about a ton of the plastic from crude could cost, let's say just as a as a rank, $5. If you make the same bag, the same ton out of recycled plastics, it's going to cost you $200. So if you are the business manager of the company that makes plastic bags, which one would you choose for your business? The $5 a ton or the $200 a ton? Mind you, the $200 a ton will make you sleep very well at night because you saved the planet, you helped all these people doing recycling down the road, you did everything possible for you, but you did not do it to your investors. They're going to come back and they'll say, you could have bought for $5 and you bought the $200. It has to be a very conscientious process in order to buy the $200 per ton bags. It happens, actually. There are companies that are doing just that, and there is a big movement in that direction. But as long as we have a good supply of oil and our industry, it's geared towards making crude into plastics, into products, that will not change. At least in the beginning. It's changing, but slowly, as long as we have the basic. When the basic is gone, probably in about 50 to 100 years, then the alternative becomes cheaper. And then everything is going to be the run-of-the-mill, is going to be recycled plastics, not virgin plastics. American Plastic Council, which is a big association of plastic manufacturers, does everything in their power to recycle, reuse, and remanufacture the recycled plastics. Just because it's a good policy, and for so many times, for their beginning of the process, the price becomes similar. Not the same, but close by. As an order of magnitude, instead of buying the $5 crude oil for their number one, they might get the $8 recycled, which is close enough for the process. So plastic industry becomes every day a better citizen. So they're not the evil out there to make big profits and everything else. They are there to make better products, plain and simple, and they have to survive in the process. So the change is there. It's getting there. So end of life, it becomes the black plastic, but also it can become another product that's so many times almost for indefinite use. You might have seen we bought for the recycling program, we bought recycling stations, those brown and gray ones. And on the side of each one of them, it says, this recycling station has been made out of 1,400 milk jugs, which tells us that recycling station, it's been made out of number 2 plastic, which is high density polyethylene, that's been colored with the colors of the university, in our case.
Sure.
And their real life, well, they're guaranteed for 10 years. But because of the additives into the material and because of the coloring, number 2 plastic in that shape would last anywhere between 100 and 200 years based on location and the abuse. So me, at least, will not survive my recycling stations. From my point of view, that one is indefinite service. So one plastic that got basically a final use, and just in case 10 years down the road, we decide that they're not looking that good, or the university turns back to the burnt orange color, so it's not our color anymore, guess what? It can be melted again, sent back to the factory and say, hey, make something else out of this and bring us back the orange ones. And they can do it. It's not going to be a problem. Technologically, it's going to be okay. And the cycle can go back. So that's the great advantage of plastics. Besides their qualities, they are replacing wood and other natural products. This one would have been out of cardboard, printed nicely on cardboard. Would it lasted long? Well, it would last about 2 years hanging on my neck. This one can last about 5. But the chances are that cardboard is going to break because I'm going to abuse it. That's one thing that humans will do to the stuff that goes into their hands. They abuse it. It's going to be hanging on something, caught in the door, folded in my pocket, which plastics can take. They can take a lot of abuse from humans. Questions?
My question, maybe you're going to get into it in the second, but we covered sort of the chemistry of 2s and 4s last time, and I know from a colleague that I work with, Patrick Brown, we've also done a little bit of pricing, to see, what's the global market price for 2s, for 4s, and also at different purities too. There's like the 80-20, et cetera. We did not really get into the chemistry of the number 1s, of the PET. Is that something we could take a quick look at? I mean, I'm happy to, maybe when you get to your demo, just Google the chemical structure. Okay. Because just, based on your discussion there, sewing initially, it's easier to get something that's transparent, then things get mixed, et cetera. I'm just wondering, for example, in a industrial process, what kind of tolerances are we looking at in terms of, what if some number 1 sneaks into that 2 or 4, how greatly will that affect the mechanical properties, the durability, and et cetera?
So what happens, and the trend is there, and the equipment is there, and the industry, it's aware, and it's ready for it. It's not 1 through 7. Actually, in the industrial process, you have tens of plastics based on those 1 through 7, what we call the 1 through 7, that are more or less recyclable. Let's put it this way, which is, we call it recyclable, but the right term would be reusable, because we cycle this, but actually we put it to a different use, or the same use, based on whatever the technology allows us. Chemically, most of them are incompatible with each other, but the technology is there at the sorting process that different plastics can be totally separated. And when we're saying totally, it's totally at the technological level. Most of the time, it's what you get, what you pay for. A simple conveyor with a blower would sort heavy from light, and that's it. It will have 2 categories, and that it's a very simple technology. You have to have somebody who supervises physically the operation. It's extremely cheap. What gets you? Density sorting, basically, light and heavy, nothing else. On the other end of the spectrum, for anywhere between 4 to $40 million. You can get a machine, and at one end, you can toss your plastics mixed. And usually you and me think about plastics like this, or like this, in objects. But once they go into the industrial process, they become flakes or pellets. So the technology accepts cut small pieces, which would be flakes, or little grains of it, melted and make grains out of it, pellets. And the machine would be sorting either flakes or pellets. So it's not sorting really lids and tacks. It's going to be sorting bits and pieces of fairly homogeneous sizes of the material. And the end of the line, the highest end of the line, will sort the plastics by density, by blowing, by vision, by color, by density, by transparency, by penetration with infrared light, with UV light, radar, and it goes through almost all the technologies and the ways of checking known to man to separate at the end in about 14 different bins that you and me, looking at it, trying everything we know, taste it, smell it, we will not be able to make the difference between one plastic and the other, but the machine knows exactly what's in it. So machines can do it in the end. It's just a matter of price. The technology is there, we just need the funding. One of the most successful companies, a startup by a chemist who has been into the plastics for all his career. It's one of the most successful sorter of them all. And they hope to revolutionize actually the recycling of plastics. Basically giving to the industry back high purity, high quality, highly sorted materials. Because that's the only limit to our recycling, the sorting process.
What's the name of the company? You've started buying stock, but
Yeah.
I think there's another TerraCycle out there is trying to do something similar with various things. Okay, well, is that a pretty good time to take a break? Unless anyone has any other questions based on the intro. That was great, Eddie. Thanks a lot. That was fantastic. So we'll take a quick break. Come back, and is the demo next?
Yeah.
Okay, super.